Okay, Martin Gaudet, please introduce the Falcon Strike.
Certainly, Nicholas, it's a pleasure to show this to you. In the beginning, the Falcon Strike concept was the shock absorber was initially developed to solve an industrial problem in a test jig that I made for aircraft landing gear. And in the instrumentation, they had a high vibration signature that spoiled the value of the measurements, and they needed a shock absorber. So I developed this. This is the actual first one, and there's a patent date of 2010 on here. This is the actual first part I made. If we consider the elasticity of steel, if we consider the efficient elasticity of steel, and compare it to something that is diametrically opposite, which is actually a 100% shock absorber. It's a shock absorber with virtually 100% energy conversion. There's no rebound. If we were to apply the Gaudet compensating damper between the gun and you could expect a substantial reduction in energy transmitted to you because the shock absorber removes a lot of the energy. We're not cheating physics, we're actually using physics to improve tremendously the behavior of the entire system. And once you get past the mechanical aspect, you begin to get into the higher shooting improvements. Apprehension, conditioning, negative conditioning, all the stuff that, you know, holding tight and the bullet going all over the place, all of those things are directly due to being afraid of the recoil.
And you had a demo where you used your model and another model. That's the limb saver.
Let's not be specific with any one.
Okay.
In general, all of the late model aftermarket recoil reduction strategies all involve a very supple. They all involve a very supple rubber or closed cell foam, which acts like a very supple spring. It does relieve greatly any pinch loading. However, we can do better than that with the Falcon Strike. The first thing that happens is the fluid-filled bladder, within about 2 milliseconds, goes and pushes equally to the bottom of the holes as well as the same as the top. It's like an all-terrain tire, like an ATV tire running over a log at 100 miles an hour. You don't even feel it because the coupling of the load is transparent to the operation. So the first aspect of the Falcon Strike is that the fluid flows to mold itself to within about 2 milliseconds. The second thing that happens that none of the other rubber-only can do is that the bladder will expand sideways as the shock wave progresses and distribute the load to 12% greater area. Now it's a small thing, but since we reduce the peak force by 50%, we pretty much have half as much physiological input as any other. And that's because it pulls up like a frog's throat.
So I just tried it, and it's a dramatic difference. I just tried it on a 300 Ultra Mag, and it's a dramatic difference.
I have graphs that I can show you.
Yeah, can you just do the hammer test again?
Sure, most certainly. So if we were to take, and they're all the same, any of the aftermarket rubber-only pads, they all act like a rubber spring. So you're not cheating physics, the spring winds up, and you get it all.
So show us the difference.
So if we were to, the bounce is perhaps 4 inches, and with the Falcon Strike,
that's the Falcon Strike.
That's the Falcon Strike. And what's happening is, because of the shock absorber, we're removing a substantial portion of energy rather than delaying it to a further point in time. And that's the whole, not a game of physics, that's the entire improvement in performance.
And you're the designer, the inventor, the developer.
100% made in Canada. We have US patents. We have a broad-based patent on the physics phenomenon, and we're also developing high-tech applications for end-of-stroke in robotics, in anti-vibration based high precision machines. We have a lot of other proposed applications as well for the base technology. So this is just a fun thing because we get to play with guns. But
amazing. It's okay.